Hello, algebra students. We're taking a look at section 4.6, multiplying polynomials. So that's the notes template you'll want to have out. We're going to take a look at multiplying a binomial by a binomial first. So we call this method when we're multiplying a binomial times a binomial. We call it the FOIL method, and probably if you ask your parents, they'll be a little bit familiar with this. It's just one of those things that sticks with you. You know, even if you don't use your algebra skills on an everyday basis. The reason we call this method the FOIL method is that we multiply the first terms by the first terms. So first, then we multiply the outer terms. Then we multiply the inner terms. And then we multiply the last terms. Now, there's nothing magical about this. It's really just a method for binomial times binomial to keep track of the idea that you need to multiply every term by every term. So that first, outer, inner, last, just a way to keep track of multiplying each term by each term. So let's take a look at our binomial by binomial, so our FOILing. So we'll multiply our first term by first term. And so that gives us a negative 2x squared. So we're multiplying that x by x. Then we are multiplying our outer terms, and so that's the first term times the last term. And so that gives us negative 4x. Then we're multiplying our inner terms, and so that is the 3 times the negative 2x, so that gives us negative 6x. And then we are multiplying our last term, so that's the 3 times the negative 4, which gives us negative 12. Now we do need to make sure we're simplifying, so you want to look for like terms after you do your FOILing, and we have like terms with the negative 4x and the negative 6x, so we want to simplify that, and as we simplify, then we get negative 2x squared minus 10x minus 12. And so you have completed the process of FOILing, or multiplying first, outer, inner, last terms, or FOILing a binomial by binomial. So that mnemonic of FOIL is all well and good, and the idea behind multiplying every term by every term is really the idea. So we need to look at what if there are more than 2 terms, and we need to keep in mind that then that's where it's important that we're just making sure we multiply every term by every term. So let's take a look at example 1 together, and again the idea is you just have to make sure you're multiplying every term by every term. There are a couple of different typical setups. There's a vertical setup illustrated in your textbook, which just kind of looks like, you know, multi-digit multiplication where one factor is underneath another, and then you have rows that you add together. Or horizontal. I'm going to show you horizontal first, that's what I'll typically use. And again, you just have to make sure you're multiplying every term by every term. So, you know, give yourself some room here. You're going to have to multiply, you know, your y times x third. And so that gives us x to the third y. And we multiply the y times the negative 2y to the third. And that's going to give us negative 2y to the fourth. And y times the 3xy squared. So that gives us 3xy to the third. And y times x squared y. And that's going to give us x squared y squared. Now that was just the one term times each term in parentheses. And then we continue, and we're going to take our 2x times x to the third, and that would give us 2x to the fourth. And we multiply our 2x times negative 2y to the third, and that is going to give us negative 4x y to the third. We're multiplying 2x times 3xy squared, and that's going to give us 6x squared y squared. And then the 2x times x squared y is going to give us 2x to the third y. So we get that kind of long polynomial there. Well, we've got some like terms, so we're going to go through and look at combining like terms. So just start out, and I'm looking for x to the third y's. So looking for the same variables to the same power. And I have x to the third y plus 2x to the third y. And so that's going to give me 3x to the third y's. Then I continue to look for like terms, and I'm looking for y to the fourth. I've got negative 2y to the fourth. And as I look through, I don't see any more of those. So I would just carry that down, completed. And then again, continuing to look for like terms, we've got 3xy to the third. So looking for some xy to the thirds. And I have another one right there as negative 4xy to the third. So 3 and negative 4 of them. So it's going to give me negative 1xy to the third. And then I'm looking for x squared y squared terms. So I want to look through for any more of those. And I have 6x squared y squared that matches that. And so together that would be 7x squared y squared. And then I have my final term here of 2x to the fourth. So I would write that 2x to the fourth. And I've combined all my like terms. Now I want to take a look and kind of be careful about putting things in descending order. So I have to go back to, all right, so I want to look at alphabetical order for my variables. So that means I'm worrying about the x term powers. And so I look for the highest x term, and that's my x to the fourth. So the first thing I would list would be the 2x to the fourth. Then I look for the next, and that would be with x to the third. So plus 3x to the third y. And then I have x squared, which would be the next one. So that's plus 7x squared y squared. And then just we have plain x, so that's negative x y to the third. And then my last term here is negative 2y to the fourth. So that's just rearranging into descending order. So starting out, multiply every term by every term. Combine your like terms, and then put them into descending order. So example 2 is your turn. I'd love for you to stop the video and see what you get, and then restart when you're ready to check. All right, so we want to make sure we're multiplying every term by every term. So I'm multiplying my 2y times xy. So that's going to give me a 2xy squared. Multiplying 2y times the negative y squared is going to give me negative 2y to the third. Multiplying the 2y times 3x squared gives me 6x squared y. And I'm going to look at multiplying my x term times everything. So x times xy is going to give me an x squared y. X times the negative y squared is going to give me a negative x y squared. And x times 3x squared gives me 3x to the third. So I go down through and look for like terms. I've got xy squared as my term, so xy squared, and so I've got 2 of those minus 1 of those, so that's just going to leave me with 1xy squared. Then I look for anything y to the third. I don't have anything else with y to the third, so I would just keep that as the negative 2y to the third. I look for anything x squared y, and I've got those two terms there right next to each other. So that's going to give me 7x squared y. And then I'm looking for anything with x to the third, and I don't have anything else with x to the third, so I just keep that as 3x to the third. So I have now multiplied everything by everything. I've now combined my like terms, so now I worry about putting things in descending order. Again, 2 variables, so I look for the one that's first in alphabetical order, which is my x. So I'm looking for the highest exponent of x, or highest power of x. And that is going to be that 3x to the third. So that will be my first term. My next power of x would be the x squared, so that will be my second term. Then the next power of x would be the 1, and so that is my next term, so plus x y squared. And then with no x variable in there at all is the negative 2y to the third, which would be last. So in this next part, example 3, we're going to take a look at being able to check or prove your answer. So first thing we want to do is just go ahead through the regular steps of simplifying this and multiplying everything by everything. So I will start that off. I want to multiply my y times y squared, and that gives me y to the third. Y times negative 2y. It's going to give me negative 2y squared. Y times the 3 gives me 3y. Then I want to multiply my 2 by each piece. So 2 times y squared is going to give me 2y squared. 2 times the negative 2y is going to be negative 4y. And 2 times the 3 gives me a plus 6. So I'm multiplying every term by every term. Then I go through and I'm going to look for like terms. I want to look for anything y to the third, and I don't have any more of those, so my y to the third stays. And then I'm going to look for anything with y squared, and I've got a negative 2y squared and a positive 2y squared. So those cancel each other out. And then I look for just the plain y, and I've got a 3y and a negative 4y. And so that is a negative 1y. And then I have my constant of 6. Now I'm hoping that that answer is correct, so let's take a look at how to check that answer. So when you're checking, we want to see if the original problem matches our answer. To do that, or is equivalent to our answer. So to do that, we want to set our original problem equal to the polynomial we have as an answer. So our original problem was y plus the sum of y plus 2 times the sum of y squared and negative 2y and 3. And our conclusion, or our answer, was y to the third plus negative y, or minus y, plus 6. So we set those equal to each other. And then we want to use any number for the variable, or variables if there's more than one, if there happens to be more than one, and to check if they're equivalent. But we don't want to use 0, 1, or negative 1, Or I'm going to add to that, I would not use 2. These can give a false positive. The 0 has special properties. Obviously, 1 has special properties. And then 2 plus 2 squared are the same thing. So, you can run into some false positives with that. But we obviously don't want to, if we're doing mental math, we don't want to keep things huge. So I will typically use the number 3 for my checking value. So again, we're just taking the original problem and we make that equivalent to our answer. So let's do that below where we have a little room to work. So you can see I've set my original problem equal to what I got as an answer. And then what I'm going to do is rewrite that, but I'm going to plug in 3 for the y value. So I'm just setting y equal to 3. So just taking a moment there to replace all of the y values with 3. And then we just continue and go through the arithmetic. Now, you certainly can use your calculator for this, and you see what you can get on both sides. I'm going to go through without my calculator here and just kind of go through the values. I've got 3 plus 2, that gives me 5 times, and in here we've got 3 squared, which is 9, plus negative 2 times 3 will give me a negative 6, plus 3. And then just on the other side of the equation, I've got 3 to the third, which is 27, plus negative 3 plus that 6. And then continuing to simplify, I get 5 times, and the 9 plus negative 6 is going to give me 3 plus 3. And on the other side of the equation, I've got 27 plus negative 3, which would be 24 plus 6. And so that 5 times 6, and then that equals 30, and 5 times 6 is 30. And so I get 30 equals 30. So that is a match. So my simplified polynomial matches what I started with. So that means it doesn't always mean it's completely simplified, so you do have to watch for that, but it does mean you have created an equivalent expression, and that is a good sign.